you need help, let me know. The first one, remember, if you have 4 terms, you should be putting parentheses and factoring by grouping. I'll go over that later with you. You got it? When you are done, check your answers for 1 and 2. Okay, when you are done, see how you did. But keep going with it. Don't look at mine until you're done. Some of you are still working on the second one, so I just put the first one up. Good job. On this one? So when you have 1, 2, 3, 4 terms, you factor by grouping. The first 2, and then you can plot x squared here, and that leaves you with x plus 1. Okay. Okay, looks like we're struggling with number 2. A few of you, not all of you, but some of you are struggling with number 2, but check number 1. Do you have questions with number 1? Number 1, remember, listen, you have 4 terms. 1, 2, 3, 4. That means you have to factor by grouping. Pull out the GCF of both, but remember when you're at this point, you have to do difference of 2 squares. It's not done. You can still keep going. And that's why you get x plus 5 and x minus 5. Your solutions, your zeros, are your x equals -5, +5, and 1. Or -1. Okay, I'm going to do number 2 with you because it seemed like a couple of you were struggling on that part. You have to ask yourself what multiplies to 8, -8 times 2, which is what? Good, -16. And adds to that middle term, which is -15. What 2 numbers did you find?
-16 and 1.
Good, -16 and 1. So these are the numbers I'm going to use when I start my factoring process. Whatever numbers you use, you're going to break up the middle term. So here we go. I'm going to break up this middle term. I get a 1x and I get a -16x. Again, we can do that because when you add them together, you get -15x. It's still valid. Okay, so then I'm going to bring down my 2x squared. I'm going to bring down my -8. From this point, it's just like number 1 because you're going to factor by grouping. So I'm going to group the first 2 and I'm going to group the second 2. Then you have to ask yourself, what is the GCF of each of the groups? Well, what's the GCF of the first one? X, or 1, x and 1. When you divide both of them by it, what's left inside?
2x plus 1.
Good, 2x plus 1. And then the second group, what is the GCF? negative 8. And I'm also left with 2x plus 1. From this point, these are common. Now the 2x plus 1 is my GCF. So I'm going to pull him out of it, and I'm going to see what's left over. So I have that 2x plus 1. And again, in blue here, that's what's left over. It's just like having a GCF problem. The 2x plus 1 is the GCF, so I'm going to pull it out, and I'm going to leave the x minus 8. Now remember, we're not done because it asks us to solve. If it asked us to factor, we'd be done. Yes?
I'd just like to say what we have to do to finish.
What do you got to do next?
First, you subtract 1 and add 8.
Good. So 2x plus 1 equals 0. I'm going to set this guy equal to 0. And we're going to subtract 1 and then divide by 2, and you get negative 1/2. And what do you get here? Just 8. So these are my two answers. Okay, so those are the solutions. Those are where the function is going to cross that x-axis. Those are my x-intercepts, technically. Okay? Questions on the factoring part? Remember, we said factoring is not going away. I promise you. The rest of the year, if you're struggling with factoring, you really need to come and get some help, either from me or during your study hall or before school when we are here. Okay, let's move on. We're going to do some things here, and I feel like it's going to be a breeze because you guys have kind of done this already. So we're going to use the graph below to solve the inequality or equation. So we have this graph, P of x, and we're going to decide when does x equal 0. Okay. No, you're good. Okay. So when does x equal 0? Well, at this point, and this point, all in purple here. What were those 3 points I just listed? They're your zeros, but what are they specifically? -2, 0, and 2. Okay, so when you're talking about when does the function equal 0, it's at those 3 points. You're just listing those zeros that you know about on the graph. Questions on that part? Okay, now it's asking when is a function less than 0? So now we have to look either below or above. Which one is it? The x-axis. Am I look below the x-axis or above it when it's less than 0? Below it. So I'm going to look below the x-axis from here to here and here to here. That's when the function is less than 0. So remember, we're describing it in our intervals. When you're describing it in your intervals, it's always going to be the x values, those intercepts that you already talked about. So from -2 to 0. Am I going to have parentheses or brackets? Good, parentheses, -2 to 0. Here's why. It just says less than. It doesn't say equal to. Okay, so the only time that you put brackets is if it is equal to. Use that little u for an and. You're all right. It's a union. Okay, so you're uniting it together, I guess, is what you would say. Okay, then I'm going to come all the way over here where it's highlighted in blue. It's 2 to where? Good. So that's something I was going to go over too. 2 to infinity. Now let me explain why it's infinity and not negative infinity, because I heard a couple of you say negative infinity. Oh. Huh? Yes, it's on my desk in the other room. It should be like on the right corner-ish side.
Okay.
Thank you. Okay, now, I heard someone explain that they wanted to do negative infinity. Here's why. You're only talking about those x values. So when you're looking at just the x number line, this guy is going towards positive because you're looking at the x values, not the y. So be careful when you're doing that. All right, this next part, I'm going to be looking at above the graph now, and it's when is the function greater than or equal to 0. So I'm going to look from this point to this point and from here to here. So again, looking at the x values, where am I starting? Good, and I'm stopping where? Good, so negative infinity to a -2, and now I'm going to have a bracket because it says equal to 0. And -2 is my 0 on this graph. Then I'm going to go from here to here, so from where to where? Good, 0 to 2, and I'm also going to have brackets on both of them. Okay, so you're describing, so if I asked you, if I was a business person, I was like, hey, when did you make profit? It would be from 0 years to 2 years. So kind of think of it in terms of like a business situation. Okay, so I made profit from 0 to 2 years because it was above that 0. Okay, so kind of just trying to get you a real life scenario. All right, moving on. I want you to give this guy a try, please, with your group. If you ever need highlights or anything, let me know. I might have a couple. Let me know if you have questions. When you're done, and when you're done, only check your hand. Totally get why you're totally understand, but you see how it doesn't say equal? Why I can't include it. So you see how this is greater than or not greater than? If it's a greater than, it's say yes to your equal. But because it says it's greater than, I have to not include it or not include that zero or not include it.
I'm so I can't. She's so close. She has like not much left.
Does that make any sense?
I like how the Inequalities of the room restrictions me and I also fix it. Like why it happened. I'm so ready.
Okay, so it looks like as I walked around, you did very well. However, this one in green kind of stumped a few of you. And I saw it very commonly when I walked around amongst you guys that you had just negative infinity to 1. I totally get why you did that, and I thought the same thing right away. But here's why you can't say that. Because this is a greater than sign. It doesn't say greater than or equal to 0. If it said equal to 0, I'd say yes, you're right. But it doesn't. It says greater than. So I can't include these points. Okay, I can't include them because they're 0 and it doesn't equal 0. So that's why I can't have it. I have to stop at each one of them. Again, if I put a little line here and I went like this, then you can describe it as negative infinity to 1. Does that make sense? Okay. All right. Let's go ahead and move on then. Okay, so now this is going to be the same exact process, but now you're going to have to factor when you do it. Okay, so there'll be one like this on your exam, and I want to make sure that you are aware of how to do these problems. Again, you can always check your answers in the calculator. However, we want to see your work with the factoring. So this is the first step. We're going to rewrite them so that we have 0 on one side of the equation. The second step is we're going to sketch a graph based off our knowledge from last chapter, where we have an even degree, odd degree. Is it going to be a leading coefficient of positive or negative? Are we going to be opening up or down, et cetera, et cetera, et cetera, et cetera. Then we're going to solve. Bless you. And solving the inequality is basically what we just did up here. We were solving. We were trying to find where the interval, what interval is going to be for that function. All right, so let's take a look at this. The first step in this problem, we're going to have to move everything to one side of the equation. So I'm going to move that 24 to the left side of my inequality here. So I have x squared plus 2x minus 24 less than or equal to 0. You have to have one side equal to 0 when you're doing this, otherwise it gets way too complicated. Okay, now we just need a factor. So I need to know what multiplies the negative 24 but adds to 2. What two numbers? 6 and negative 4. So I'm going to go right to the very end because it's one of those situations where the a value, this leading coefficient, is 1. So I can go right to the very end. So then I'm going to have x plus 6 and x minus 4. Okay. Then again, we have to solve it. I need to find my zeros. What are my two zeros now? Negative 6, good, and positive 4. So those are my zeros. Those are going to be those x-intercepts on the graph. Okay, my second step in these problems is to look at the leading coefficient and the degree. What's the degree? Is it going to be even or odd? It's even. So we have a degree that's even. And is our leading coefficient positive or negative? Positive. Good. So I have a positive leading coefficient. Again, you don't have to write all these steps down when you're doing these problems. I'm doing it for your notes so that you can kind of look back and see what my thought process is when you're doing this. Okay, so with that then, am I going to be the same direction or opposite directions on behavior? The same, because it's even. Okay, and am I going to be concave up or concave down? Up. Good, good, good. You guys know so much, it's pretty cool to see. So now I'm going to sketch that graph. I'm going to put negative 6 is probably somewhere around here, and then 4 is maybe somewhere around here. If you want to be really perfect with it, you can. And you guys told me it's concave up, so it's going to look something like this. Again, you can always verify with your graphing calculator because you can use it on the exam, you can use it on something like the SAT for the most part. Okay? But make sure that you're able to at least get through this process. You're going to have to show your work for factoring. Okay, so now our very last step here is just to solve the inequality. So the function, when is the function less than or equal to 0? So that's what we're describing. We're using this guy. So if you have a highlighter, I would make sure you highlight that. Okay, that's what we're looking for. When is the function less than or equal to 0? So from this point in pink to that point there. How would I describe that interval? Yeah, negative 6 to 4. And like I heard, it was going to be brackets. That's our final answer. Okay, just like above on the first page, but now you had to do the graph yourself. Okay, that's the only difference. Do you have questions on that part? Are you sure? All right, let's do the next one. First step is always to do what? Good. So we're going to put everything out over to one side of the equation. In this situation, it's going to be the left side of the equation. So we're going to move it over. But make sure you put it in standard form. Otherwise, it's going to be very hard to factor it. So when I subtract that 8x squared over, make sure it goes in the middle because you want it in standard form. Because otherwise, you're going to get stuck when you're factoring. Like, how can I do this one? Well, here they have a GCF. What's the GCF? X. Yes. So we're going to go ahead and GCF here. We're going to pull it out and divide each one by x. You're going to be left with x squared. Good. Minus 8x plus. Good. Okay, so from here, go ahead and factor this piece because that's really all you need to do right now. You have to factor that piece. The x squared minus 8x plus 16. Okay, that one should be an easy one because your leading coefficient is 1. You ask yourself what multiplies the 16 and adds the negative 8. Multiplies the 16, adds the negative 8. What did you guys get? Good, a negative 4 and negative 4. Okay. Negative 4, negative 4, when you multiply them, you get positive 16, and when you add them, you get negative 8. That's why that one works. Final step on this number 1 step here is just to write out the zeros. I have x equals 0, x equals 4, and then we have another x equals 4. Well, I don't have to write that twice. Okay, you can kind of maybe just draw an arrow that also equals x equals 4 too. Now, on the exam, something that you're going to have to do is explain that this guy has a multiplicity of 2. Okay, that's something that you're going to have to make sure that you understand. So, the x equals 4 has a multiplicity, I'm bad at spelling, so please let me know if I spell this wrong, of 2. Remember when it has a multiplicity of 2, remember it kind of has like that, it hits that x-axis and then bounces back up. It never really continues to go straight down. So when we draw our graph, we have to make sure that that's on there. So now our step 2 then, do I have an even or an odd degree? Odd. Okay, let's talk about that then. So we have an odd degree because you're looking at the very, very beginning here, and that's our odd degree. And I have a positive leading coefficient. So let me just sketch out my graph. Again, you're more than welcome to go in the graphing calculator and graph this and then sketch it yourself. That's fine. But we want to see the factoring part of it. Okay, so then I'm going to go ahead, I'm going to graph this out. I have a 0, and I have that 4. If I have an odd degree, I know that there's going to be opposite end behaviors. They're going to be going opposite directions. If it's positive, it's going to be increasing. It's going to be trending that increasing. Okay, so it's going to look kind of like a snake. So it looks something like this. Now remember, right here at 4, it bounces back up. That's what it is to have a multiplicity of 2. It bounces off of that x-axis. This was our 4. This was our 0. Do you have questions on number 2, on that second step? Okay, last and final step is just to describe what it's asking for, because this is mainly the goal, is to figure out when is the function something. So let's look. Greater than 0. So when is the function greater than 0? So take a second, see if you can describe that interval yourself.
Joe Leonard. Joe Leonard.
Leonard. So greater than 0, there's no equal. Does it say now or when convenient? Let me see. Yeah, you gotta go. Okay, what did you guys come up with? What was the first interval? Good, 2. Good. Then what's the next one? 2. Very good. Okay, remember, a lot of people were asking me this question, why can't I just put 0 to infinity? You can't, because it says greater than. There's no equal sign. You can't just do that. But we're going to get to a situation where we can, which is going to come up here. I want you to try letter C. Okay? I know there's a lot of factoring here, but you got it. Try C. Everything's already to the left side. They really don't have to do anything there. It's all set up for you. So try C. Stress that factoring is not going up. A lot of you are doing very, very well at factoring, and we're super happy because last year we had a very rough time because a lot of kids couldn't factor. You guys have definitely had that skill, which is amazing. I think factoring is one of the biggest tools as you move forward in math. If you plan on doing any math outside of Math 3, which a lot of you are going to have to if you go to a college or university, factoring is probably the biggest thing that you're going to have to know going in there. I just put that very first step up just to start checking as you go so that you don't, make sure that you don't have any mistakes. Yeah. Well, then I can't possibly get them, right? These ones are a little different. Because I just changed the last name based off of the exam. That's why looking at that instead of the equal. You guys are doing good with this. This is awesome. One of the questions that was asked, which I feel like a lot of people would have that question, that gets stuck on step 2. This is what determines right here, that degree and leading coefficient. The 3 is your degree. If you get stuck, make sure you write that somewhere. This is your degree, and then this is your leading coefficient. Okay, the degree is 3, and you have a positive leading coefficient. That's how you figure that out if you get stuck on that second step. I'm going to move it over just so you can kind of see if you're doing it correctly for step 2. And last guy there, check your answers. My biggest tip to you is, whenever you're describing intervals like this, they're always going to be your zeros. They're never going to be anything else. You should never have like 5 or negative 5 because it's not a 0, so you wouldn't really describe it. Okay, so sometimes in the exam we would get like a random number. I'm like, where did that come from? Okay, so make sure that you're just using those zeros when you're describing intervals. Give you one more minute just to make sure you have everything written down correctly. Very last one's very fast and very easy, so you should have a good 10 minutes, 12 minutes to do your homework. Do you have any questions on this one? When I watched around, a lot of you were doing very well. But did you have any questions on where I got something? Okay. All right, then I'm going to move on to the very last one here. What's really nice about this one is it's already factored for you. Okay, so there could be a situation where we give it to you and it's already factored for you. So for this one then, my first step would just be to write out my zeros. I have x equals what? And is it -1? Just +1, very good. And good. So which one of them has a multiplicity? Good. So this is a huge thing that you're going to need to have to know. This guy has a multiplicity of 2. Why? Because it's squared. Okay, that means that it's going to bounce off that x-axis. So now we can already move on to our second step, which is to talk about the degree and the leading coefficient. So this one might be a little bit more challenging. I have 2 x's here, 1 here, and 1 here. So what is my degree? 4. So is it even or odd? Even. So I have an even degree. And do I have a positive or negative leading coefficient? Negative. Okay, that's this guy. All right, so now I can go ahead and draw out my graph. I have a -3, which is somewhere over here, a 1, and a 6. It's even and negative, so I know it must go down. And that multiplicity is at this -3 point. 1 and 6. So that means I'm going to have some kind of bounce back there. I'm just going to, boom. Okay, so that's kind of how I do it. If I know there's a multiplicity, I kind of draw like a little parabola there, and then I continue the arrows. So again, it's asking now, when is the function less than 0? Less than or equal to 0. So now here's that situation where a lot of you were like, well, why can't I do that? This is a fun one because now you don't have to break them all up. You can just talk about that all those pieces right away. So from here all the way to here and from here to here is when it's less than or equal to 0. So this one, again, we don't have to talk about and stop at each one because it says equal. So I can start at negative infinity and I can stop all the way at 1. That was a fun one because you didn't have to break them all up. And I'm going to include it. Then I'm going to go from 6 to where? Good, 6 to positive infinity. Remember, if you ever get stuck, you're just talking about those x values. Do you have questions? Awesome. Okay, remember your test is Friday. Or math, yeah, will be due at, we'll say 4 o'clock tomorrow in case you come to tutoring. So that would be a lot of no, so this negative is telling you that it's going to be counted down. This, when you distribute it, if you were to distribute all of this, you're still going to have a negative exponential power of some sort. Don't cause too much work for yourself. You don't have to distribute in that situation. I'll make a key really quick.